All right, so in the morning, I realized that students forgot the delta epsilon thing, so let's talk about that briefly before we go on. So again, do you remember what it means to evaluate a function at a number? So for this example, the analogy that I like, that I thought of, is that you have a water gun and you feed a particle C into the water gun and the particle shoots on the wall, and f of C is where it lands on the wall. It's exactly the point at which the particle touches the wall. Understood? When you take limits, you do an entirely different process. So you see, I hope this is just a picture, but I hope you are seeing an animation, a video. And in this video, we have water gushing out of this pipe, the horizontal pipe. And there is a lead at C, so I'm not putting in C. And the stream is splashing all over the wall. Part of the stream might enter the red pipe that I have over here. Okay. Now, why is that the analogy that I'm using? Remember what happens when you calculate limits. Without any formulas, without anything, what's the picture that you should have? Well, I have this opening on the x-axis, the interval, and I begin to squeeze it smaller and smaller and smaller. Yes? And as I squeeze that interval, I expect the water to get focused, the current that's coming out of my turret to be focused more and more around the point L, if that's the limit. So before I continue, guys, do you understand what I say, what I'm saying? Good? Alisa, good? All right, I just look, at least when I see some faces, I can see if you are, you know, exhausted. Wonderful. So you understand, whenever you think about delta epsilon, forget about the formulas. They will not make sense unless the idea that you are trying to capture, it's a description. What are you trying to describe, right? If I told you to write an essay, you would not know what to do, right? Mostly about what should I write an essay? But I give you a topic, then you know what is it that you are trying to describe. Same situation here. You need to know what is it that you're seeing, what is it that you're describing. And when people say mathematics is a language, they mean precisely that. They mean that that you can very, very precisely describe a situation. Okay, but it's still a description very often. Okay, so what you're trying to describe is the idea that if you are making the pipe on the x-axis narrow, the stream coming out of the turret will be on L, will be focused to L. Good? Now, so what I do here when I try to capture the idea of focused, I say, well, let's say that for me, focused will mean this width, this interval. So I open up a pipe, center of the pipe is L, and the length of the radius is epsilon. Now, so that maybe it's more precise for you guys, what is that epsilon? What is, to your best ability, without looking anywhere, what would you say is pi, the number pi? What is it equal to? Please type in the comments and let's see what you say about the number pi. So two people say 3.14. One person, okay, so 3.14, 3.14, 3.14. Okay, so a bunch of 3.14s that I see here. Anyone knows pi a little bit better than 3.14? Oh, Christian says 3.141529. I actually don't know the 29, and somebody copied and placed a huge expansion for pi. So, okay, so do you see, guys, when you say 3.14, let me just ask you the next question. 3.14, is it really pi? Is 3.14 really pi?
Well, it's approximately, but not exactamundo.
Exactly. It's Alan. Exactly. It's approximate. So you say no, it's not pi. Now you understand what it means. So when you say 3.14, that means you know pi two decimal places after yes, 2 decimal places. That's what you know, right? So then if you don't know more, then I can lie to you. I can say that maybe the other decimals will be, well, 3.1471, for example, right? Maybe that's right, maybe not. So when you say 3.14, that means you are a machine for detecting whether or not something is pi. Are you follow me? You're like a machine. You can your task is detect, is it pi or is it not pi? When you know only 2 decimal places, your error margin is, let's say, in the order of 10 to the minus 3. You understand? Because let's say first decimal place is 10 to the minus 1, second decimal place is 10 to the minus 2, and 10 to the minus 3 is the next decimal places. Okay? So roughly speaking, you follow me, guys? Yes. Roughly speaking, that means that your epsilon for that pi is 10 to the minus 3. It means that if roughly speaking, if the center is pi, then the top part of the pipe is pi plus 10 to the minus 3, and the bottom is pi minus 10 to the minus 3. Okay. So if you have a current focused on this number, you might, you see, so whatever gets into this region, whatever point is a distance from pi is less than 10 to the minus 3, you will regard as pi. It will be a good approximation for you as pi. If you are a better detector, then your pipe is narrower. It's a thinner pipe. You understand? Because let's say if you know 5 decimal places, then maybe 10 to the power of minus 6 is your ability to tell the error. It's basically 10 to the minus 6 is, after that you cannot tell whether it's pi or not pi. Okay. So particles entering this region means that the machine will detect and say every particle that enters into this pipe. The diagnosis machine will say, oh, it's pi, it's L. Okay. Any particle that enters in here is an L-like particle, so the machine will think it's L. You understand how the argument works? So the idea is that you will be able to fool, if this current is getting thin around L, you will be able to conclude that every particle is in fact, that lands inside of it is L. Okay, so no matter how thin is the target pipe, you should be able to squeeze the domain pipe tightly enough. So here for this target pipe, this delta is not good enough. I need to have better approximations of C. That's when I squeeze the pipe thinner, and still it doesn't work for this delta 2. But if I squeeze it even thinner, now all the particles are entering the red pipe. You with me, guys? All of them are entering. So and here is, that's a dynamic process. You prove delta epsilon by showing that for any opening, no matter how thin is that opening on the y-axis, I will be able to squeeze the pipe on the x-axis tightly enough so that the water current enters into that very thin red pipe. Okay, so I have this plumber type of analogy here. Did you understand what it's supposed to capture? It's supposed to capture the idea that as the inputs get focused around the point C, the outputs get focused around the point L. Okay, and focus here will be measured by what particles enter the pipe. Is it understandable completely, guys? Go ahead, Zoheb.
Yeah, quick question. You hear me?
Yes, I do.
Okay, so you see where you put the epsilon, where it's between L and L plus E. Will it also be between L and L minus 3, or is it just that specific place?
Well, sorry, the epsilon is the radius. Okay, so it's L plus epsilon, and L minus epsilon is the opening of the pipe. The pipe extends from L minus epsilon to L plus epsilon. Epsilon refers to the radius of the pipe. I speak of pipes here in terms of their radii. Okay, I know where they are centered. They're centered at L. That's the epsilon pipe. It's centered at L, and the delta pipe is centered at C. Okay.
Oh, okay, I got you.
And when I have this delta epsilon argument, what I try to do is I try to explain how can I focus the current to enter a pipe this thin, and if we make it a different thickness pipe, how can I make the current go into that different pipe? Okay, so if I can always accomplish that, that means that the current gets focused around L arbitrarily. You see, you understand, it gets more and more focused. I can make it arbitrarily well focused at L if I can push the current to enter any pipe of any radius. Make sense, the idea, guys? I explained it many times, but maybe it's redundant, but in my experience from other classes and also from my last class is that it might not be as redundant. Yes? I hear awkward silence, which means something is not understood, or?
I got it.
Hello.
I don't speak for everybody, but I do get it.
Okay, thank you, Pavel. So other type that you understand, or you need some more explanation? I'm still slightly confused, but I think I got it so far. Guys, you see, understand the idea. D to Alan means that what? So you're confused, or do you get it, Alan?
Well, I'm slightly confused, just like Rafid, but I think I got it for the most part.
Well, you see, the best thing that you could possibly do if you're ashamed to do it in class for some reason, you know, you're young, so you might be ashamed of public speaking. Others will think you're stupid. Well, you know, it's ridiculous. I don't think you're stupid if you talk to me, right? If it matters to you.
Okay.
So you can just, what you should do, guys, is either after class or during class, maybe try to word it your way. Okay, try to explain how you see it. I'm explaining. I think I make sense, but I need to hear you. Okay, so this is the idea of the proof. I hope you follow it. So, do you remember how we did this problem? Yes, we proved using delta epsilon that if x goes to 2, then 3x minus 1 is 5. Now, how did we do that? Let me go over the argument again. You see, and that's what I think when you find mathematics boring, that's because it's like you are watching a movie in a language that you don't understand without the video. That's really what happens. Understand? So imagine you turn off the TV and you hear certain sounds, and the sounds are not interesting because you don't understand them and you see nothing. So it's very much like that. So you know what I imagine when I do this? I'll tell you a few things. Maybe they will excite you, maybe not. But you know. So let's begin asking this. Okay. So 3x minus. So I have x going to 2 of 3x minus 1. It's intuitive that the answer is 5. Okay. Obviously, for such problems, delta epsilon is not an argument I would be using at all. It's just I'm trying to illustrate to you how the idea works. Okay. So it's not the problem that matters. It's really trying to train you to understand delta epsilon. Okay. I think of it as working with your sonar. Okay. So imagine this. So I have 3x minus 1 minus 5. I say it's less than epsilon. How can I make that statement? 3x minus 1 refers to what exactly? Would anybody dare and tell me? 3x minus 1 is what? In terms of particle, to be more precise, right? So we have particles, we launch the particles in the torrent. That's my analogy. So in terms of that analogy, what is 3x minus 1?
The canyon?
Sorry?
The canyon?
Well, thank you for speaking, but the canon is the function. In some sense, I see what you mean, but you see, 3x minus 1, there is no x, correct? There is no x. But what I mean by that no x, guys, so you understand, when I say a human, I am talking about every single person. So x is just a way to talk about some general object. You understand? In that sense, there is no x, right? There is Arthur, there is Matthew, but x, human, it's just like it's a grabber. It's something that picks something up, and 3x minus 1 does describe how the function works. But let's say in terms of the situation, I think of it this way. I think x is the particle being fed into the machine, if it's located at x, and 3x minus 1 will then be what? Where the particle ends or splashes against the wall. That's exactly where it hits. Okay, so 3x minus 1 is Treffer, where the particle hits. Okay. Well, the reason I say Treffer is for many reasons. You might already know that I lost my mind. But the other thing is, of course, I speak German, right? And I was influenced by quite a few things that I was watching regarding that, right? So 3x minus 1 means that's the place where the particle landed. 5 is my target, correct? 5 is where I wanted to land. So what is absolute value of 3x minus 1 minus 5 less than epsilon? What does this statement communicate? So you suddenly hear a message, 3x minus 1 minus 5 absolute value less than epsilon over. What do you interpret it as?
The radius around.
What did I communicate? You say I spoke weirdly, and maybe that's why you are bored. But I'm not bored because I understand what was said. In fact, because it was said in a weird way, it makes it more exciting. It's poetic, right? What did I say?
Is it the radius around the target?
Well, the radius is epsilon, so radius is part of it. But what did I truly say?
Did you say this current location is around the epsilon area? If I'm saying that right, maybe?
That's not bad. Maybe you have a perfect idea of it, but maybe a slightly better phrase. For example, you see, guys, you're actually good at it. If I say black stripe, white stripe, black stripe, white stripe, what am I talking about possibly? Type in the comments or tell me. White stripe, black stripe, white stripe, black stripe. What am I talking about? My God, how good are you? You see, I was so big, and right away you tell me what I'm talking about. Why are you able to do it here and not in the other situation? It's exactly what I am doing here. Right? So what am I truly trying to communicate? Get to the heart of the matter. What is that?
Can I, all right, so I don't know if I'm right. The difference between where you want it and where it landed, the absolute value would be that many units has to be less than the radius.
Yes, that's spoken correctly, absolutely, but maybe say it simpler, right? So you understand if something like this happens, maybe you can hear it, okay? Look, you cannot see it, but maybe you can hear it. Let's see if you can. Yeah, ready? What happened, right? So you describe it like this. There was boom, boom, or something, right? That's what I hear as a description. But get to the gist of it. What happened? What did I do just now?
It went within the range. Well, for the problem.
What did I do? I mean, this is a stupid
you
question.
You opened and closed the door.
Oh my God, I opened and closed the door. My God, you gave me such a simple description. What happened here?
An input went within the range that it's supposed to.
That's very big. You say there was it's like what I hear now is there was a jarring sound followed by a moment of silence followed by another jarring sound. That's what I hear your reply as, right? So it's true, but somehow it's avoiding the heart of the matter. That's what I feel. Maybe I'm wrong, okay? And I'm forcing my analogy. I'm really sorry, guys, you know, that I'm forcing my analogy, but what else can I do? Here, this is what we're talking about, correct? We're talking about this. What happened?
It hit it below the epsilon, is that?
Exactly, or in particular, particle entered the pipe. That's as simple as that. Particle, whoop, entered the pipe. Okay? Do you understand what I'm saying, guys?
So that's what that L part is? It's a
L
pipe?
pipe is the target. So you see what I do? I squeeze, that's the target. I want the current to be focused around L. When limit exists, that means whenever I squeeze the current around C, it will come out focused around L, okay? And how do I communicate that? I say open any pipe around L. The particles will eventually all be entering that pipe. Do you understand? All of them. If they're coming from a pipe around C, they will all be entering that pipe, no matter how thin that target pipe is. That's why I have to be abstract. That's why I have to be epsilon. I try to communicate the idea that you can always, no matter how thin is that pipe, squeeze the domain pipe enough and the particles enter. Are you with me? You see also.
So,
wonderful, Elisa.
So you're saying that the absolute value equation that you asked what that means, that the simple way to say it, you're saying it went through the pipe. That's your answer?
Yes, it's exactly my answer. You see, good that you're laughing. I see your faces and some of you are laughing. It warms up my heart, truly, right? What else do I have? You understand, guys? I mean, that's what's bothering me. You see, you watch this thing. Why are you bored? If you are bored, it's because you are not seeing an animation or a picture. When I'm not seeing that, I would be bored as well. But I'm seeing so many things, right? So many things I are seeing or imagine that I feel them. Don't drive around in a car with me. It's dangerous. Truly, because when I start thinking, I can space out. I stop hearing, stop seeing, and I'm in another universe, right? And then I remember one person was driving and he was doing everything to survive. I could see it in slow motion. I just was looking at him like this, like I am transcended. I have transcended, right? And he's like, right? He managed to survive. Then he looked at me very angrily like this, and I look at him like my soul is already somewhere very far away. And so he gave up, he left, right? It's useless, right? When I have a car accident, somebody starts screaming, I just Calm down. Everything's okay. Anyhow, let's go back to the topic. Yes. Drugs? No, no drugs. I don't use drugs. I use mathematics. So it's much, much better, right? So some people tell me, take LSD, you will start seeing fractals. That's terrible. You know, I see fractals all the time. I don't want to see them. So, all right. So back to the, I'll show you what I see soon. Our next lectures, in 2 lectures or so, we will have very scary lectures. I'll tell you what are my nightmares. Okay. So what we have here, where are we? So in here, guys, do you understand what happens here? So here is how I get this statement. I imagine that I do something, right? So when you are there at the, what do you call it? When you are at the control, you are closing. Imagine you are a seaman and you are closing the pipe, right? You're closing the pipe so that the water is gushing correctly, or maybe I don't know what you prefer to imagine, seaman, or what do you call the other thing? Plumber. Yeah. Okay. So you're squeezing this. You have not been paying attention to it. You were just closing the lid, and suddenly you realize every particle is entering into the pipe. So this is communicated here, right? This is a particle landed into the pipe of size epsilon. So the next thing that you do is you look at your indicator. What was the distance of x? What was the proximity of x to 2? So you're looking within this equation information about what was x minus 2. You follow? So this is how you think. You imagine staring into this pipe. You're closing the lid, and suddenly you see the current getting into the red pipe. And then you start paying attention to your domain pipe and ask yourself, how thin must it have been? What was the radius of that pipe? If you can give an answer to this question, that means you figured out how to close the lid properly for every target pipe. You with me? So this is what you do then, right? So epsilon is bigger than 3x minus 6. I can factor out a 3. And I have 3 times absolute value of x minus 2 is less than epsilon. So x minus 2 has to be less than epsilon over 3. So that means this. You see this? So I just verified. Particle enters the pipe of size epsilon. Particle was inside of a blue pipe of radius epsilon over 3. That's what this means. Okay? You see how I did it? Particle enters the pipe of size epsilon. That means particle started from a pipe of size epsilon over 3. That's my delta. Easy, isn't it? Very easy.
Wait, do you mind repeating what you just said?
Which part of it?
When you explain this whole statement?
The whole statement, yes. So I'm saying, okay, my goal is to show that I can focus the current around L, where L in this case was 5. Good?
No,
Carolina,
I get that. I meant
Okay.
like, you see where it says x minus 2 is less than epsilon over 3?
Yeah,
Can you just explain what the x minus 2 would refer to?
it refers to where X is in relation to my domain pipe. X is going to 2, which means my domain pipe is centered around 2.
Oh, okay, I see.
You understand? Absolute value of x minus 2 means distance of x to 2. And the distance of x to 2 less than epsilon over 3 means what? It means the domain pipe. You see? Any x that's coming must be from its center no more than 1/3 the radius here. You understand how I do it? It's very simple. I just interpret what it means. It's just a strange way of speaking about things that are extremely simple. But it does it so very precisely. So that means that all I have to do is close the domain pipe to 1/3 the radius of the target pipe, and the water gets in. Do you understand what this means? So give me a target pipe around 5 of radius 1. I will select domain pipe of radius 1/3. If the target pipe is of radius 1/2, I will select domain pipe of radius 1/6. Always 1/3 of the target pipe. Do you understand? And then by this formula, I ensure that if I do so, the current coming from the domain pipe enters entirely into the target pipe. It's very simple. Okay. Now let's try again. I think we did it last time. Let's see if we can progress a bit better. What about this one? And don't worry if you're wrong. It's easy to be wrong with them, right? I'm just wondering what you would say. Okay. So
We did this one.
I know, but but people have very short memories, like goldfish memories. Don't look into notes. See if you can do it. Mustafa, by the way, are you here, Mustafa Ahmad? If so, right, yes. Mustafa, are you here? That's one thing I mean, guys, right? So when people come here and don't show their faces, I am not sure if the person is even in the class. Okay, good. Well, good, Muhammad. Good, good. Let me know, guys, when you're ready, and we will proceed. All right, Tarek, but is it just epsilon over 9 or something else is there? There is, by the way, not one answer to this, naturally, because you can make a pipe listing, and if you make it thinner, it also works, okay? So it's not like there is a unique answer to this question. All right. One more minute, and we will do it together.
Is it called set? I don't remember.
Sorry?
Like the weird, like E, like 3 reversed.
3 reverse? Ah,
Yeah.
so it's called epsilon.
Epsilon.
All right, let's work it together, guys. So again, let me remind you what's the common mistake. So The answer can be many things. Okay, depends on what's your setup. Okay, so here is how many students proceed initially. So they say, well, that's before. Imagine we close the pipe, the input pipe, and suddenly we realize that the input points are landing within 16. You see, so the particles are landing within the target 16 less than epsilon, which means they're entering the pipe of radius epsilon around 16. You understand what this means? So I squeeze the pipe, and I imagine particles are landing within epsilon away from 16. Oh, wonderful. Then the question is, how close was particle X to 4? So I'm interested in this part. So you can factor it out. You have X plus 4X minus 4. Absolute value of a product is the product of absolute values. So we have absolute value X plus 4 times absolute value X minus 4. And then what the students are doing, they simply say X minus 4 less than epsilon over X plus 4. Would anybody tell me what's wrong with this answer? Intuitively, right away you look at it, you should say, well, the answer is obviously wrong. Why is that wrong?
You can have a function as the denominator, or not
so
a function.
you mean X in the denominator?
Yeah, denominator. Yeah.
But why? What's the problem? What should you see? What happens if I have absolute value of X?
Because you basically don't want to have like I think in like your reference, like the size of the pipe change.
Well, absolutely it does. Wonderful. You see it perfectly. So right away I look at it and you see it's obviously wrong to me because I see that as you are squirting water out of your pipe, it's not the same pipe. It's always changing size depending on what X is. You see, because having X here means that select a particle smaller to 4, the pipe is wider. Yes? Because dividing by smaller number makes it wider. So select a larger number, the pipe is narrower or wider. So the pipe changes shape, it's just incorrect. And here I just gave you an example. If you plug in 4.001, you get this is your delta. And if you plug 4.01, it's a different delta. You want a fixed pipe for all the particles coming from the domain near C. So what do? Here is the trick that you might use. So clearly the domain pipe is squeezed. It's getting smaller. You don't need to work with thick domain pipes. You agree? Because the domain pipe, when you take limit, you are taking approximations of C. X goes to C, or in this case, X goes to 4. I'm taking approximations close to 4, so the pipes are narrow around 4. Yes? Very narrow around 4. Which means what? Which means, yes, so which means that I might as well select in my toolkit to work only with pipes whose radius is less than 1. 1 or less if you prefer, okay? So all the deltas are 1 or less. Here you could actually have strict inequality because X minus 4 is not ever equal to delta, it's less than delta, but that's not very important, okay? So what I want to do is this, okay? So suppose that X minus 4 in absolute value is less than 1. What does it mean? It means that the number inside of the absolute value is between -1 and 1. Yes? Everybody is with me, guys? You see, this is an obvious calculation. Absolute value of a number less than 1 means the number is between -1 and 1. Wonderful. So if not, guys, you stop me right away. I can explain the same things a million times. And after in office hours, again, I have infinite patience, truly. If it's a question, right? I don't like statements. So when you say, is it on the exam? It's a statement. You're saying, I'm not interested. That's what it is, right? But if you're asking me about conceptual things, that's endearing. Anyhow, so that means X minus 4 is between -1 and 1. Yes, Rafi, what should I do? Wait, where? What should I explain? The number on the left be 0, not of absolute value, right? X minus 4 itself is between -1 and 1. Okay, I'm not saying absolute value is clearly bigger than or equal to 0, but X minus 4 is between -1 and 1. Because why? Look at it here. There is a number inside of the absolute value. The number has magnitude less than 1, which means it had to be either negative to, and therefore, but magnitude number size is less than 1, or, well, it's basically this. X4 is between -1 and 1. Clear?
Wait, can you hear me?
I do.
What I'm wondering is, you stated that absolute value, no matter what, it'll never be negative, right?
Absolute value is never negative, yes.
So, like, when you said -1 is less than or greater than x minus 4, like, what if, like, that means that -5 might be the number in the middle, right?
-5 is not between -1 and 1. -5 is.
I mean, -0.5. Excuse me. Sorry.
-0.5, yes.
But like, there's no way to get negative. So wouldn't like the number be 0 on the left?
Well, be careful. Absolute value is not negative, but then think about it. Take the absolute value of -0.5. It's 0.5, and 0.5 is less than 1. Do you agree? So what you do is you take all the positive numbers that are less than 1 and all the negative numbers that are bigger than -1. It's just the absolute value, it folds. Okay? You see, think about it this way. The x minus 4 might kind of confuse you, but really it's just an absolute value of a number is less than 1. What can you say about the number? Its magnitude has to be smaller than 1, right? Or the distance, or this is just distance between this number and 0. Absolute value of any number is the distance of this number to 0. Okay?
So no matter what, it has
value
to be
of -5, I'm measuring the distance between 0 and -5. Okay? So I took a number, I measured the distance to 0, and I got that it's less than 1, which means the number is on the interval between -1 and 1, because those are the only numbers that are not very far from 0. Either you are to the left of 0 or you're to the right of 0. Okay, you can think of the negative axis as pretty being exactly like the positive x-axis, just going in the opposite direction. Make sense? Good.
Yep.
Wonderful. I hope it clarified. Okay, so you see, so then inequalities, you get used to them. Again, one thing that you should practice. What don't you know, Alex? What bothers you? So we will mention it. So just epsilon over 7, I don't see how you would do that, right? But there is no unique answer. You understand? You described, it's a process you describe. You say for a target radius, how to make it fit. Anyhow, so I decided 1. There is no reason to decide 1. You could have decided to make x minus 4 less than 1/2. Okay, it's just an arbitrary size pipe that I decided I will not work with pipes bigger than it. You follow the idea? I don't because the delta pipe can be made small. The delta pipe can be made very small. We will do so. It's not 7 times x minus 4. You will see that I don't want to use the small value. I want to use the big value, the 9. I want to use. Okay. So I begin to manufacture x plus 4 here. Everybody understands what's the idea of this one. There's nothing special here. I just know that deltas are in general going to be small. So I decide to not work with deltas bigger than 1. That's just an arbitrary decision in this case. You could have decided not to work with deltas bigger than 2 or bigger than 1/2. It doesn't matter, because delta in general, when you do the limit, delta will be small, because that's just approximation of the, in this case, of the number 4. X has to be an approximation of 4. Good. So then we have x plus 4 is between 7 and 9. And that means that that's what the absolute value of this number is. It's already a positive number. So the absolute value of this number is in particular smaller than 9. So here is how I work it out. Look at it. Absolute value of x squared minus 16, it's this product. And if I assume that delta is less than 1, then x plus 4 is less than 9. So I can put a 9 here. And if I also assume that delta is smaller than epsilon over 9, then this part is smaller than epsilon. Do you agree? If this part is smaller than epsilon over 9, a number smaller than epsilon over 9 times 9 is epsilon. It's smaller than epsilon. Okay, so I have this chain reaction. Okay, so the delta that I want to select is, let's say, the minimum, because I want this condition to hold. The delta should be the smaller of the numbers 1 and epsilon over 9 in this case. If I make this delta, that will for several things, because if x minus 4 is less than this delta, it's already smaller than the smallest of those two numbers. So it has to be smaller than epsilon over 9. If it's smaller than epsilon over 9, 9 times x minus 4 is smaller than epsilon. But x minus 4 will also have to be smaller than 1. So that means that x plus 4 times x minus 4 will be smaller than 9 times x minus 4, because this 9 is this calculation under the assumption that x minus 4, the distance between x and 4, is less than 1. Easy, right? You understood how I did it? So then with those two calculations, I figured it out.
I got a quick question.
Go ahead.
I don't understand why you that's the I wrote it down on my notes, but I still didn't understand why you did 4 minus 1 and 4 plus 1 on both sides, and then you added 4 plus then you added 4 on both sides again. I just don't.
Yeah, I did it. I hope that doing it this way will be. I would not have been bothered like this. I would do it in one step. You understand? My goal is to manufacture x plus 4, because that's the part that I don't like. I don't like this part. I just need information about x minus 4, because x approaches to 4. You understand?
Okay.
My goal is this: if particle is entering into a pipe of radius epsilon around 16, how close was the particle to 4? This is the information. This is just saying how close is the particle to 4. X plus 4 is something that I don't want. It's garbage that I'm trying to get rid of. So with this inequality, I know what's the range between x minus 4, and my goal is to find what is the range of x plus 4. So I see it's between 7 and 9, and I pick a bigger number. The idea is the entire process here is to get rid of this part. I replace it by a number, and then I can do what I did in the previous example. You follow, James?
50-50.
50-50. Okay, that means no. Okay, so where do I lose you?
It's like, so in the problem, right? It's just like, all right, so you did 4 minus 3, you did 4 minus 1, and then 4 plus 1, right? I think that's the part that kind of.
Well, look at it. I'm getting x, so inequality, right? So the numbers, this number smaller than this number, smaller than this number. If I add the same number to all of them, it's like I keep the same distance between them, right? I just transport the numbers elsewhere, but they preserve their relative distance to each other, correct?
Yes.
I add a number. So for example, if you have $1, I have $6, right? And somebody has $11, right? So the difference between us is $5, right? And if I add another $5 to everyone, the difference between us would be $5. So that's really the same thing that happened here. I added, instead of $5 here, I added $4. So I add 4 here, 4 here, 4 here, and that preserves the inequality. They keep at the same distance from each other.
Oh, okay. Yeah.
So yeah, so just numbers. What I do is it's inequality, but if I add 4, it does not change the order of the inequality. I add 4 here, I add 4 here, and I add 4 to the middle guy. That's how I get this line. But I actually need to add 8. I could have done it in one swoop. I would have added 8. I just kind of wanted to show you slower. I'm not sure if that helps or not. Because I don't care about x. Somebody, Rafid, I think you asked me about where did x go. I don't care about x. My goal is to get rid of absolute value x plus 4. I want to replace it by a number. That's what I care about. Absolute value of x plus 4, I want to find a bigger number than that. And what do? I manufacture x plus 4 in this inequality, and then I have a 9 here. So x plus 4 is positive, so I can put absolute value, and I know that x plus 4 in absolute value is always less than 9. And that's what I picked. And Alexei, you mentioned 7. I don't want 7, because 7, the inequality is in the other direction. I need this.
I have
you
a
understand
question.
why? I want to go from this to bigger and then less than epsilon. You understand?
So why do we want to get rid of the x plus 4 and not x minus 4?
Because again, we want information about the distance of x to 4. Distance of x to 4 is absolute value x minus 4. I need to know, that tells me how where the particle started. What was the pipe it started from, right? So for example, if I have x minus absolute value of x minus 4 less than epsilon over 9, right? That means that I'm within a pipe which is epsilon over 9 units. If I have x minus 4 less than 1, let's make it simple. X minus 4 less than 1 means x is inside of a blue pipe of radius 1. You see what I'm saying, right? So this part absolute value x minus 4 less than something communicates the distance of x to 4. And that is, it tells me what is the radius of the pipe around 4. Well, the thing is, you can make delta small. Delta controls the size of the pipe around 4. So you cannot start with x plus 4. You understand why? Because what can you do here, guys? If you forget about what you described here, you are only able to make the input pipe wider or narrower. Around what point is it wider or narrower? Around the point 4. And the radius is then communicated as absolute value x minus 4. You understand? This you can make as small as you like, because that's what you're doing. When you're pushing x to 4, you're making the distance between x and 4 smaller. That means that you are making x come out of thinner input pipes. Make sense? It's a matter of communication, guys. You just have to realize what is it that you are seeing. Wonderful. If you did, it's wonderful. That's actually how you had to be very good in mathematics if you were a submarine commander, which, by the way, it's pretty interesting that I found it's not natural that actually my birthday is the same as that of Karl Dönitz, who was the U-boat admiral. So the Atlantic War, the U-boats were all under his command. And what you had to do if you ever watch the movie U-boat, splashes, right? What you do is you use sonar and you try to figure out based on equations, right? Where do you shoot the torpedo, when it explodes, how to time it, right? It was completely blind. You cannot see anything. You're in a metal can and you have to navigate inside of a metal can. That's exactly what you do here. And that's exactly what you do when you launch a satellite. You don't see it. You just have to interpret a signal that it sends. For example, when you launch a Martian lander, a Mars rover, how do you know it landed? It sends a signal. It just sends you a signal, landed, distance, whatever it is, but you cannot see it because the distance is so large that you cannot live stream. It cannot be live streamed. The speed of light will take some time to reach it. You understand? So it's a similar thing. You are talking about the current. You're predicting what happens about it without ever seeing it. That's what you're doing. You're using another sense. Good. Let's try this problem, guys. See if you get it. It's a bit difficult. I hope you can do it. Limit as x goes to -1 to x squared minus 5x minus 2 equals 5. Can you do it? Let me know when you are ready. All right, ready. So this is what we do, guys. We take absolute value of 2x squared minus 5x minus 2 minus 5 less than epsilon. That's what we want to accomplish, yes? And we are seeking information about absolute value of x plus 1. In other words, this is what happens. Particle landed at this position, and it was found to be very close to 5. Close enough to enter the pipe of radius epsilon around 5. You follow? That's what the statement means. Particle entered this pipe of some arbitrary radius epsilon. My question now is, I was able to accomplish it. My question is, what was the radius of the input pipe? So I factor it out. It's x plus 1 times 2x minus 7. Which part do I want to get rid of? This part or that part? Let me know which part to get rid of.
2x minus 7.
Exactly, 2x minus 7. So I begin with the same assumption. I'm gonna work with only pipes smaller than in radius than 1, yes? So it's x plus 1 between minus 1 and 1. That means that x is between, go ahead, Alex.
Okay, so I mean, I don't like the second part, that's why I got rid of it. But why would that be, like, specifically? Is there like a good, like, because it technically it's negative. So how would that be, like?
What is negative? You mean 2x minus 7 is negative?
Oh yeah, it's like.
But it's an absolute value. Absolute value of 2x minus 7 isn't negative.
Okay.
Yes?
Wait, so absolute value of 2x minus 7 is not negative?
2x minus 7 is negative, but in absolute value. I don't need 2x minus 7. I need absolute value of 2x minus 7. That's what I have here. Absolute value x plus 1 times absolute value 2x minus 7. Yes?
No.
Wait, I have a question as well.
Yeah.
When you said, why did you choose 1 again? Like on either side?
Well, not either side. It's this. I said that all my pipes, my input pipes are all less than 1 radius, 1 unit radius.
Yeah, like
yes.
What makes -1 and 1 the deciding numbers?
It's just if the absolute value of some number is less than 1, the number is between -1 and 1. So for example, suppose that I have absolute value of some number, and it's less than, the absolute value is less than 5. The number I'm having is between what and what?
4 and 6.
So why is it you are putting absolute value where I did not? Absolute value of x plus 1 is less than 1, but x plus 1 is between -1 and 1. There is no negative here. Maybe I'm not sure if you're seeing a negative where there shouldn't be. That's 1 and that's -1, and that's just x plus 1.
Yeah. Okay. So
right,
so right now
connected it. I accidentally wrote a minus, but notice I connected it. So you see, I don't see it because I mean, obviously a -1 here would not make sense.
what we were calculating here is if x is going to -1, right?
Yes.
Oh wait, it says it's if x is going to -1. I'm sorry, never mind.
Yes,
I got it.
-1, right? Good. So it's x plus 1 is then between 1 and -1. Make sense? You know the absolute value, guys. Take an absolute value. If the size of the number is less than 1, the number is between -1 and 1. If the size of the number is less than 5, the number is between what? I'm holding a number, its size is less than 5, but the number I'm holding is between what and what? Please type in the comments. I need to say inequality.
If it's 5 or if it's less than 5?
This is not this problem. I'm just checking basic logic here, right? In my fist, I'm holding a number. Its magnitude is less than 5. The number is between which two values?
So for the second part, you plug in what you would get if you put in -2 and 0.
Too complicated. The absolute value of something between -1. Sorry, the absolute value of some number is less than 5. Absolute value is less than 5. So between which two numbers? What the number I'm having here? Its magnitude. Yes, exactly, June. Between -5 and 5, guys. You see, that's one of the things that it's prerequisite for this class is to know such inequalities, right? If you don't, we can talk about it. I can try to help you, but that's not supposed to be part of this material. You understand, guys? That's one reason I'm going slower, and that's why reason you would some of you will be a bit worried about when we go to the next chapters. It gets a bit denser. I know I try to keep it as far as possible, but you do need to review this. It's very simple, guys. If the absolute value of a number, it might be that you have $5, or it might be that you owe $5. You understand? So the magnitude of the number is 5. If I say I will give you some money, and the magnitude of this money is 25,000, you should not be right away too happy to receive it. You should not assume you get between 0 and 25,000. Maybe I'll take away 25,000. You understand? If I say I will give you some money in the magnitude of 25,000, that does not mean that I will give you 25,000. I might take away 25,000 or anything in between. Good. So x plus 1 is between -1 and 1. That means that I subtract 1. So x is between -2 and 0. You follow? And then I made it a bit faster. You'll say I multiply by 2. Multiplying by 2 doesn't change the order of the inequalities. That would be 4 and 0. And if I subtract -4 and 0. And if I subtract 7, -4 minus 7 is -11. So 2x minus 7 is between -11 and -7. Good?
Wait. Can you repeat how you got -11 again?
Just I need to produce 2x minus 7. So I multiply by 2 and subtract 7. So if I multiply everything by 2 and subtract 7, that's what I get here, right? So -2 times 2 minus
Okay,
7 is
I got you.
7. 0 times 2 minus 7 is -7. I do all those procedures. So make sense? Review, guys. Remember I mentioned the appendix, right? So review that or stay after class and we can talk about that a bit longer if you need to. Good? So what we have now is that absolute value of this number is definitely smaller than 11. Because the number is between -7 and -11, in absolute value, it's smaller than 11. Good? Good, guys? You're not fried yet. Or are you? Okay, Christian. Good. What about the rest of you? Not yet? Eric, what's troubling you? Where are you lost? And others don't respond. I'm assuming they lost consciousness. Ah, good. Consciousness pulse is there. Good.
I'm still not fully understanding why you removed the left side and
What?
make it absolute. I don't understand how you remove the left side and make it an absolute value.
I don't remove anything. I just know, I just use basic common sense, you might say, right? Well, 2x minus 7 is a number between -11 and -7. What's the magnitude of this number? This number never exceeds magnitude 11. That's it. You follow? If the number is between, let's say I'm saying I'm gonna take away between -11 and -7 from your pocket, right? Between 11 and $7 from your pocket. Then how much must you have in your pocket for me to be able to do that, right? You don't need to have more than $11. You understand?
Okay.
Or you see, maybe you haven't been robbed enough, right? I'm not sure where you're living there. Good? It's very simple, guys. You should know it better than me. So the number here is between -11 and -7, which means what's absolute value? See, I'm not just looking at lines. It's not just some algebra. I just realize what it means. It's obvious from here that this number is in magnitude. When I take absolute value, I'm talking about the magnitude of this number or the distance of this number to 0, right? So this might be saying that you walked, if you just take this to be the number z, that means you walked between 7 miles and 11 miles to the left of 0. Okay, so how far are you from 0? No more than 11 miles from 0. Do you agree? Maybe you are 7 miles from 0, maybe a little bit more, but no more than 11 miles from 0. That's from here. Yes, because you see, -11 is a marking that blocks your movement further to the left. You agree? So here is 0. Here is -11. You don't go farther than -11. It's like your milestone. You follow? All those things, they communicate, right? They communicate something. Good. So then I have this absolute value of 2x minus 7 is less than 11, which means what? Which means that absolute value of x plus 1 times absolute value of 2x minus 7 is less than 11 times absolute value of x plus 1, as long as my delta is equal or less than 1, right? If delta is 1 or less, that would work. And this will be less than epsilon whenever absolute value of x plus 1 is less than epsilon over 11, as long as delta is less than epsilon over 11. You see that? We have those two conditions, so my delta of epsilon is minimum 1 epsilon over 11. Good? You follow me, guys? All right, I will skip this. It's a bit abstract. Good. Rewatch it, reread it, guys. Think about it. It's not the delta of epsilon, the only thing that I'm trying to help you with. It's a small thing, but I'm trying to improve the way you think about those things, right? So it's very visual if you are thinking about it right. I don't understand anything I cannot imagine, right? If I don't imagine it, I'll forget it immediately. Here is a new question, okay? So in this case, I'm pushing x to 1/2 of 1 over x, and the answer is 2. This limit is 2. Good? Now the question is, okay, so if the limit is 2, first of all, I cannot select any delta I want because 0 is dangerous, right? If my pipe is centered at 1/2. So the biggest delta I can select is 1/2. So here my delta will be definitely less than 1/2, and I chose it to be less than 1/4. You understand? So that I'm safe away from 0, which is a danger zone. I don't want the interval to contain 0 because particle launched at 0 is undefined. You follow? So clearly this interval is getting shorter and shorter, smaller around 1/2, so there is no problem there. Yes?
Yes.
Wonderful. So I select delta less than or equal to 1/4, and then I begin my process. So absolute value of 1 over x minus 2. This is just, I can give them the same denominator. So I have 1 minus 2x over x. And then I'm searching within this expression, I'm searching absolute value of x minus 1/2. So I realize that if I factor out, well, first of all, I don't like the x on the bottom, I factor it out. And from the numerator, I factor a minus 2. Do you see that? Factoring the x and factoring the minus 2 from the numerator. So factor the x and just look at the numerator and factor out the minus 2. So you will get this expression. Minus 2 times x, and then minus 2 times minus 1/2 will give me this one. Good? So then I have a product, the product of absolute values. Well, absolute value of the product is the product of absolute values. So I have this. This is my garbage. This is my thing that I want to get rid of. I want only x minus 1/2. Good? I'm moving quickly through it because I want to speed along, okay? So then what do? I begin to manufacture 2 over absolute value of x. So I already assume my delta is no more than 1/4, so x minus 1/2 is between 1/4 and minus 1/4. And then I manufacture x, I just add 1/2 to both sides, and then x is between 1/4 and 3/4. Just add 1/2 here and add 1/2 here, you get 1/4 and 3/4. Now, when I take reciprocals, right, I take the reciprocal of this number, the reciprocal of this number, the reciprocal of that number, the inequality is split. You understand roughly why, right? Because this means that the smaller the denominator, when the bigger is the fraction. The larger the denominator, it makes this fraction small. Turn it around, it's now upside, in reverse. Okay. So when I flip, I get 4 bigger than 1 over x, bigger than 4 over 3. Hopefully you understand it, but I don't want to spend too much time just on that part just yet. Okay. This is inequality is something that again supposedly a prerequisite for this course. Again, guys, don't be intimidated. If you don't know that prerequisite, I will explain. But semester is short, so do it mostly in office hours. So we have this, and then I multiply by 2. I have that 2 over x is between 8 and 8 over 3. So absolute value of 2 over x, it's a positive number. So absolute value of 2 over x definitely smaller than 8. So I carry out this calculation, and I get that delta of epsilon is the minimum of 1/4 and epsilon over 8. Okay, that is the delta epsilon proof for this expression. Good. So all those examples are not at all examples for which you do use delta epsilon, to prove limits. What you want to do is you want to prove that limit laws are true. Okay, that's one interesting test, right? So can you prove that, let's say, the addition law is true? So limit, suppose we know that limit as x goes to a of f of x is L and limit of g is M. Can you prove that f plus g goes to L plus M? Okay? Because if you have the product law, the addition law, many of those calculations will be obvious. So I began talking about triangle inequality because I assume you might not be aware of it. Okay, so on the number line, so triangle inequality in general is expressing this idea that in Euclidean space, the shortest distance is directly through a line connecting the 2 points. Okay, if you take a roundabout way, you will move longer. Okay, that also works on a real number line. You can start suppose you have to move from A to B. So if you go through the intermediate point C1, that's not causing the distance to be longer. You see, so absolute value of B minus A equals to the distance between A and C plus the distance between C1 and B. That's what this is expressing. I don't even need to do any calculations to observe it. Just this segment plus this segment, yes? But if C is located, let's say, to the right, and I first want to move to C2 and then to B, then I will move a longer distance naturally. I would move through here and then extra distance here and then back. Okay, so I move a longer distance. So regardless, the inequality holds is that if you take any arbitrary point in between, your distance might be, your trip might be longer. The distance that you travel might be bigger. Okay. Of course, intuition isn't enough. And here I give a proof of that triangle inequality. That basically the triangle inequality states that for real numbers, the absolute value of B minus A is less than or equal to absolute value of B plus absolute value of A. Okay. Let's see if we can prove this limit law for addition. Are you tired, guys? Or if you're tired, we can move to the next topic and return to this one later on, so that I don't cook your brains uselessly. You want to move to the next topic, or do you want to continue with delta epsilon today? I will return, of course, to this topic next time if you prefer to move. Let me know, and do it now, please. The next topic is easy. Move on, yes. Move on for now, and then and then I can come back to it later because I see some eyes and I think we already glazed. Well, so I think it's best to maybe move on, okay, for now. And I will return to this topic again. Next class, we will try to talk, try to read the notes, guys. Maybe you will understand what I do here. But don't read too much. I want to see your reaction. I want to see if you understand abstract, right? So the questions I will ask for extra credit will be abstract, because that will tell me whether or not you just memorize the procedure or you understand how that works. All right, so let me switch to a different screen. Okay. Okay, guys, so this is the question. So are you ready? First, watch this cartoon for a little bit.
So now,
can you hear it?
I want to sing a song just for you, 'cause you're my special friend.
Now, I showed you this clip for a particular purpose. Why was it scary?
It wasn't.
Well, yes, I didn't select a very scary video, but it was supposed to be scary. And by the way, you might have had warning, you know, it said something scary, something you probably saw it. I didn't say it was scary, but something about it was supposed to be jarring, right? You watch horror movies, and then tell me what's so scary about those scenes. You know, I would have showed you in class, it would be so much nicer. But imagine that you know, you have this video, you have this scary person standing somewhere very far in the hallway. Lights flicker, the person still stands very far. Lights flicker, the person stands very far, and it's suddenly right. Right in your face. What's so scary about it?
You don't expect it?
Unexpected, yes, but something else. What's scary about it, I think, is disruption of something that you find very familiar, but yet maybe not know how to define. It's continuity. There is a continuity of motion, right? When you see something moving, my arm is here. I mean, you might imagine there's a glitch, so you're kind of used to it. But if my arm, if you saw in real life, my arm was here, and suddenly my arm was, let's say here, right? So my arm is here. I'm here near the screen, and suddenly I come at you, and suddenly I'm right in front of you. Like I come out, and I'm right in your room. You're terrified. Why are you terrified? It's because I traversed huge amount of distance in no time whatsoever, right? I teleported in a sense. Okay. And teleportation is disruption of continuity. And if you see a very good eerie disruption of continuity, you might find it very frightening. Okay, so here is what we mean by continuity. So first of all, every curve can be imagined to generate, every function, my apologies, it can be imagined to generate a curve. Okay, you don't always see this curve, but some curves are like a piece of string. You can draw it in one motion, and others you cannot draw in one motion. Okay, so the following graphs are showing you curves that cannot be traced in one motion. For example, here there is a hole, so I go around, trace it all in one motion, then suddenly I'm here. I have to lift up my marker, and I have to then trace it again. You see? Good. So we are trying to understand mathematically what is it that we mean that something is torn apart or there is a hole near some particular point A. What does it mean for the function to be discontinuous at that point? So again, that would imply that the graph is somehow not one piece, or there is a tear in the graph at the point A. You understand? So which of those tears do you imagine are worst? Okay, among the picture 1, 2, 3, 4, which do you imagine is the worst, the most torn graph?
4 because it has the most waves, like shock waves. That's why I think it's 4.
Maybe, why not? Maybe 4, right? But nobody says 1, right? Nobody thinks that 1 is the most disturbed or torn apart or damaged curve. Okay, so we're using the word continuous here or whole, even though we haven't yet defined what it means. We just have some vague intuitive sense that this is almost intact. And then this, there is separation, so it's somewhat less intact. Maybe this and that are even less intact, okay? So let's see what happens here, okay? So in here, look at it. If I move my cursor from the right, that's limit as x goes to a. The limit exists, and the limit from the left also exists. They converge to the same location, okay? So whenever the limit as x goes to a exists, then there is only possibly a hole here, but no more, right? So when the limit exists at x equal to a, that means that we have the two parts of the curve, they merge to the same location. Maybe they're not fused, but they merge in the same location. Okay? Okay, good. Now in here, would anybody tell me what happens in terms of the limit here? In 2a.
Function.
Sorry?
It transitions to a different function from y equals.
Hey, that's one function. You might transition to a different piece, but
Or-
not in terms of the limit. So limit as x goes to a of g of x. Does it exist?
I mean, the limit ends at some point, no?
Who was speaking? Alisa was speaking?
Yes.
Okay, say it again.
I said that the limit ends, and that's what I
You see, it's fine, but when you say ends, I worry that it might be vague to you, right? That you think, what is it that you mean that it ends? Could you phrase it differently? So this limit, and thank you, by the way, for speaking. I really enjoyed it, right? So this limit of g of x as x goes to a, does this limit exist?
It does.
Well, you see, that's what I mean. But so this limit, guys, look at it carefully. How does the limit exist? If I approach a from the left, it means I'm already over here, right? So if I approach from the left, I go and go and go, and I get to L. So limit as x goes to a minus is L. The left limit exists, okay? If I try to take the limit from the right, it also exists. The limit from the right exists, and it's M. But the limit as x goes to a does not exist. You see why? Because it depends on the direction from which you go. You get part of the, if you go from the right, you're getting to M. If you go from the left, you're getting to L. And they are not the same. So this function is defined at A. This is the point. The function at A is defined to be M. And, but yet the limit doesn't exist. So when I say limit as x goes to a of g of x exists, I'm saying that the two curves merge in the same point. That's what I communicate. You see, when I say if x goes to a, g of x approaches to some value, then I'm really saying in terms of the curve that as I trace it from left or right, like I'm showing with my fingers, the fingers merge in the same location. So I am getting at least this situation. Understand?
Professor?
Yes, go ahead.
I'm a little confused. Can you go over again what you meant by like the L going from the left and why it's not?
Well, here, right? So x going, this is the graph of the function, right? So that means that if x is here, I'm somewhere over here, right? And if I make x go closer to a, then what happens? My altitude is decreasing. You see? So really, when I move my cursor, imagine drawing a line connecting the cursor to the x-axis. Yes. Okay. So now imagine pushing the x towards a. That's going to a from the left. In other words, from below a, right? So that's called x going to a minus. So the particle is going to walk this way, and it will reach the value L. Make sense? So if I start from the left, I walk it, and then it reaches the value L. If I start on the right, the particle is here. As I move x towards a plus, the particle gets closer and closer to here, to this M. So that means that that the left-hand limit exists and it's L, and the right-hand limit exists, and it's m. But the limit, the unqualified limit, as I go to a, does not exist. There is a hole here. There is a tearing, right? So that so when I say simply limit as x goes to a of g of x exists, I mean the situation at least. So if it discontinues, then maybe there is a hole at most, because the two curves merge in the same location. Understand? So when I say limit exists, that's the same as saying the curves merge in the same location. Okay?
I see. Okay.
And now we look at 3, guys. What happens at 3? Does the left-hand limit exist? If I take limit as x goes to a, do we have existence? Exactly. It doesn't exist because what happens is that as I move towards a, I just get larger and larger values. It appears forever, right? So the numbers just get bigger and bigger and bigger, but I don't approach a particular value. In terms of the crane, in terms of the water gun analogy, it's like I shoot the water current higher and higher and higher, and the water particles are just reaching further and further up, but never merge at a particular point. And they might be still very spread, right? So this limit does not exist, and it's a pretty bad non-existence because neither the left side nor the right side exists, right? So there is no merging. In 4, the situation, it's hard to say 4 is worse or better. That's somewhat a matter of opinion. In this case, it looks like the right-hand limit exists and equals to k. But the idea here is that if I move from the left, this is supposed to be infinite. I cannot draw it, but I can give formulas for which this is true. Because to draw it fully, I have to draw infinitely many peaks and valleys. Okay, so what happens is I move in, it just starts oscillating, and it oscillates more and more and more. Okay, so the limit from the left does not exist. Here, neither left nor right limit exists, and here the left limit does not even show any clear pattern of increasing or decreasing. It's just oscillation. It's called divergence by oscillation. Good. Empty hole means it's undefined. Shaded hole means that it's defined, because shaded hole means just you're focusing on it. If there is a hole, it's just a focus on it to tell you that there is something missing here. If it's filled in, it means you can stand. That A is defined to be this capital M. Good. So this is just me describing what I just mentioned before. And here is our definition of continuity at point A. Okay. So if I take a marker from the right, I trace it. I should merge to a point, and the same point I merge if I move from the left. That's what the idea, right? Moving from left to right, I merge to the same point. That's the same as saying that this limit as x goes to a exists. And this means what? And this means that where they merge, it's actually filled in. It's defined, right? So basically, the fact that this limit is equal to f of a is just to preclude this situation, right? Where the curves merge in the same location, but there is a hole. In other words, if I were to pull the string, the string will not be attached. You know, it will come apart. You understand? So that's the definition of continuity. It's this formula. You understand why, again, guys, right? You might memorize this definition and not understand why it's capturing the idea, or maybe you don't agree. It's fine if you don't agree and you can tell me why. Does this idea capture the wholeness or connectedness of the graph at the point A? Okay. I think, well, let me know what you think before I say what I think. You understand it? It's also a description. Why is this the definition of continuity at the point A? Because it's supposed to, again, the goal is to capture the idea of wholeness of the graph. The graph near A is somewhat one piece. That's what we're somehow trying to communicate. Yes, guys?
Can you repeat what you want us to say, Professor? I didn't hear you.
Yes, what I want to hear from you, perhaps it's a lot to ask, but do you? I want to hear a comment about why do you think this describes wholeness near one point, or if you think it doesn't describe, you can tell me why. By the way, maybe you would be interested to see a prisoner. That's my prisoner. I have many. 1 second, I'll let him out. Hey. Okay, anyhow. So, any comments, please?
I have a question, Professor.
Go ahead.
So you see how you wrote down that x is going to a. Why is that not including negative a as well?
No, it's from all directions.
Oh, so when you say that, it's all directions. You don't have to specify positives or negatives.
Yeah.
I got you.
The positive or negative, it would be above a, not in front of it. In front would be minus a. You put a sign above, means, so this here would be a plus, and here, that's a minus.
And then if it's coming from both sides, you just don't put anything and just leave it.
Sorry?
So you just explained to me that if it was coming from the negative, you would put a negative, and if it's
Yes.
coming from the
So
positive.
here the green line will be a with a negative on the top. The blue would be a positive on top of a. Yes?
Right. So if it's coming from both directions, you just
Then
don't
you don't
specify.
specify it. So this means
I got it.
unqualified. It means come from any direction, and you are asking whether or not you get a fixed value, right? So you see, this is just a formula. What it means that evaluating a limit is the same thing as plugging a into the function. Do you see that? It's what a lot of novice students, they think, well, what is a limit? Just plug whatever value you have here into the function. And why do they say that? Is that most of the time for the simple functions they use, it works out. You understand? They get the right answer. If you get many times the right answer, you start getting confident, even though perhaps your understanding is incorrect. So you see, continuous functions are those functions where calculating the limit does not do anything, because this more complicated process gives you the same result if you just simply plug in the value a. But my question is, why this limit captures the idea of connectedness? You understand what you want to describe? You want to describe gradualness or connectedness, and connectedness is one piece. That's what you do in analysis. It's pretty complicated problem. I actually can explain what the definitions are, but you see, you look at my arm and you imagine it's a solid object. It's one object. It's not going to come apart, right? But on the other hand, if you look at my cell phone and my soda can, those are two objects. Okay, what makes them two objects and what makes it one object, right? So this is a solid wholeness, right? That's what you try to capture with this definition. Would anybody try to explain, or should I do it? Because I can explain it, but why is this definition capturing wholeness at the point A, or maybe it does not? What you're trying to say here is that this string, you see, it's a string. It will not come apart and near the point A. You understand? It will not come apart. That's what you're trying to say. You see, like over here, it's like this. So Pavel, you even said those are two functions or two curves, because in your mind you look at it and you say, oh, they will come apart. This piece and that part are not attached. Here they are very close, but they are not attached. You see, so the left part to A and the right part from A are not attached. Here they are not attached, and here they're not attached. So you're trying to capture the idea of curve being attached or together near the point A. You with me? So why is that a good, you understand what I'm hoping? I'm afraid I will explain this forever, and next class you will kind of not know again. It's just an interpretation. I look at this and then right away, oh, somebody tries to communicate wholeness or attachment, or that the string does not come apart. Why is that the case? You see the idea? Okay, somebody wants to say, wonderful.
Isn't it almost like the same thing to your a car analogy? How let's say it's going by a speed light, right? A speed and light, right? So as let's say A is where or close to that range is where the car hits the red light, right? You want to have a specific calculation with the limits of how fast was he going through the red light in that specific area, if I'm seeing it right.
Well,
It's kind of
that was why we motivated limits here. But in here we're trying to talk about a string, and whether or not the string is one thing attached to object, or is it not attached near A. Yeah, so again, I will try to say for this example how I see it. So you spoke about one particular limit which ends up being the derivative. We'll end up talking about it more and more later in the class, James. What we're trying to capture here using the idea of limits is this. You see, look at it. The curve is one piece. At least it will not come apart if I were to pick this curve at A. Why not? Because look at it. I trace it, and the left part of the curve, the left part from A merges, and the right part merges to the same location. Okay, so the pieces of the curve, they are attached. But then I might have this problem like with my fingers. You know, my fingers are touching, but I can move them apart. Okay, what I want them to do is to say that, okay, where it moves in, it's fused. You see this red point at A, that's exactly equal to the limit. So there is a fusion there.
Okay.
I have two curves, like my fingers are touching. And how do I try to demonstrate it? I just move my left cursor and I move my right cursor, and they merge in the same location. That means this limit exists. You see, from right and left and qualified limit, this part exists. And because it equals to f of A, the fact that it equals to f of A means that this point is fused. There is a point right on this curve over there. What?
Oh,
if
Go ahead.
If it were an open circle and if it were
you could pull it apart. The open circle is just an indication that, like with my fingers, there is no circle. The circle you might imagine a ring, but it's not a ring, right? It's like with my fingers. You see it touches, but I can pull it apart. So that means that there is no definition at this one point where, or it's not defined properly at this one point, so that it's attached.
Okay.
Make sense?
Yeah.
All right, guys. Wonderful. So we are out of time, and I feel always bad keeping you. I will stop recording, and if you have questions or want to talk a bit longer, please don't hesitate to do so.